Okay, so this question wants you to determine the number of significant figures that are in each measurement. So there are 5 rules for recognizing significant figures. Not all of them are going to be applicable, but anytime you have non-zero numbers, they're always going to be significant. And anytime you have zeros that are between any non-zero numbers, those are always going to be significant. If you have zeros that are going to be to the right of the decimal, these are going to be significant. And anytime you have zeros that are to the left, these are called placeholder zeros, and these are not going to be significant. So if you're looking at this first example, these first 2 zeros are not significant, but this 0 is. So if you look, you have 1, 2, 3, 4, 5 significant figures. If you look at this second example, all of these zeros that are to the left of your non-zero numbers are not significant. These are placeholder zeros. But these non-zero values are significant. So 3 significant figures for this one. For part C, you only have non-zero values, so all of these values are going to be significant. So you also have 5 significant figures. And for your last one, all of these zeros to the left of your non-zero numbers are not significant. So you're only going to have 2 significant figures. And so one way of checking or kind of, showing that these values or these zeros to the left are not significant is we can also rewrite this in scientific notation. So if we were to write this in scientific notation, we would write 4.9450, because again, this 0 is significant. Anything to the right of the decimal point is significant, so we have to include it. And if you look, we go 2 decimal points, so times 10 to the negative 2 seconds. And you can see again, 5 significant figures. If we move this 1, 2, 3, 4 to the right, and we convert this to scientific notation, it's 4.82 times 10 to the negative 4 milliliters. This value is already in scientific notation. So again, this has 5, and we can convert this last into scientific notation as well. So it would be 8.4 times 10 to the negative 3 milliliters. And because we only include the 8.4, has 2 significant figures, 5 significant figures, 3 significant figures, and 5 significant figures.